These are the trains that will reshape the world and the ones that may never get built. Right now, across 6 continents, governments are pouring hundreds of billions of dollars into a transportation revolution that promises to make flying between cities obsolete. But for every gleaming bullet train that rockets across the Chinese countryside at 350 kilometers per hour, there's a half-finished rail line buried in political gridlock, environmental lawsuits, and cost overruns so staggering, they're almost impossible to believe. This is the future of high-speed rail, the triumphs, the disasters, and the mega trains that could change everything. Start with the numbers because the scale of what's happening globally is genuinely difficult to take in. The world's high-speed rail network has reached approximately 65,000 kilometers in operation. Another 16,600 kilometers are under construction right now. That's enough track to wrap around the Earth more than twice, with thousands more kilometers being laid as we speak. And when it comes to high-speed rail, one country dominates the conversation so completely that every other nation is essentially playing catch-up: China. In just a few decades, China built a high-speed rail network that surpassed 50,000 kilometers in December 2025. That's more than 75% of all the high-speed rail on the planet, concentrated in a single country. Between 2021 and 2025 alone, the network grew by 33%, climbing from 37,900 kilometers to over 50,000. 45,000 of those kilometers sustained speeds of 350 kilometers per hour, and they're not slowing down. In January 2026, Beijing unveiled a plan to expand the total operational rail network to 180,000 kilometers by 2030, with high-speed routes alone reaching 60,000 kilometers. The Chinese government describes this transformation as going from follower to frontrunner, and that's not an exaggeration. Their newest model, the CR450, has been tested at an astonishing 453 kilometers per hour and is expected to enter service soon. Meanwhile, the strategic focus is shifting from simply building more track to something even more ambitious: intelligent dispatching, automated driving, and robotic maintenance. China's railway industry has launched what it calls an AI plus scientific research initiative, essentially trying to make the world's largest high-speed rail network also the smartest. The environmental impact is significant too. High-speed rail in China drives an annual reduction of 11.183 million tons of CO2 equivalent greenhouse gas emissions, representing about 1.33% of the entire transport sector's output. And that number climbs every time a new line opens and passengers choose rail over air travel. Now cross the Pacific because the United States tells a very different story. The nation that put humans on the moon, that built the interstate highway system, that pioneered commercial aviation, still doesn't have a single operational bullet train. The California High-Speed Rail Project was supposed to change that. When voters approved Proposition 1A in November 2008, the vision was compelling: a bullet train connecting San Francisco and Los Angeles, transforming travel in the nation's most populous state. The price tag at the time was $33 billion. Ambitious but achievable. Fast forward to today. Construction began in 2013 and more than $18 billion has been spent. The current estimate for Phase 1 sits somewhere between $89 and $128 billion. That's not a typo. The project has nearly quadrupled in cost, and the most optimistic timeline for the initial 171-mile segment between Merced and Bakersfield, not San Francisco and Los Angeles, just Merced and Bakersfield, is no earlier than 2033. To be fair, it's not all bad news. The project has created more than 16,400 jobs and generated nearly $25 billion in economic activity. 55 structures and 70 miles of guideway have been completed. A massive 150-acre southern railhead facility stands finished, ready to serve as a hub for receiving and storing high-speed rail materials. And in February 2026, the authority issued its draft business plan, with Chairman Tom Richards stating it sets out the path forward: completion of Merced to Bakersfield, expansion to major population centers for revenue-positive service, and early asset commercialization to produce additional revenue. In June 2026, the project took another significant step, executing a co-development agreement with Momentum Alliance Partners. a global consortium that includes Plenary Americas, CDPQ Infra, Keolis, SNCF Voyageurs, Jacobs, and several other major infrastructure firms. This public-private partnership is positioned to help finance and deliver future expansion, but the project faces a potentially existential threat. In July 2025, the Trump administration terminated approximately $4.2 billion in federal funding, citing 9 compliance failures, including a $7 billion funding shortfall and the failure to procure a trainset vendor. California sued, then dropped its lawsuit in December 2025. The state has secured $1 billion per year in cap-and-trade program funding through 2045, but the authority itself acknowledges this level of funding isn't enough to complete the system. So California's bullet train lumbers forward, too expensive to finish easily, too far along to abandon, and too politically charged to discuss calmly. But California isn't the only high-speed rail story in America. There's another project that might actually beat it to the finish line. Right Line West broke ground on April 22, 2024, with plans to connect Las Vegas to Southern California along 218 miles of dedicated high-speed track. The numbers are enticing: top speeds of 200 miles per hour, a 2-hour and 10-minute journey time, 11 million expected annual passengers, and an estimated 400,000 tons of carbon dioxide reduction every year. Construction has created over 35,000 jobs, surveying work has been completed along the entire route, and work began on the Las Vegas station in mid-2025. Siemens Mobility is building a 300,000 square foot, $60 million facility in New York to manufacture the train sets, with production scheduled to begin in 2026. Executive Director Michael Reininger has been publicly confident about the pace. As you can see when you drive by the site we're building today, it's underway. But there's a catch. As of March 2026, Brightline West is still waiting on a $6 billion federal loan needed to fund construction. The company told investors it's simultaneously pursuing a $4 billion loan from a banking consortium. If the federal money doesn't come through, the entire $6.5 billion project could stall. The target completion date of late 2029 is looking increasingly optimistic. Then there's Texas, where a proposed high-speed rail line between Dallas and Houston has become one of the most dramatic infrastructure sagas in America. The Texas Central Railway would cover 240 miles in under 90 minutes at speeds between 186 and 205 miles per hour. The safety argument alone carries serious weight. Interstate 45, which connects the two cities, ranks as the second deadliest road in the entire United States. Texas Central estimates the line would remove about 15,000 vehicles from that highway every single day. In August 2024, the project received a $64 million federal grant, but then Congress defunded $928 million in high-speed rail grants, devastating the project's funding outlook. Meanwhile, Dallas reaffirmed its ban on elevated high-speed rail through core parts of the city, forcing transportation officials to explore alternative western alignments through Fort Worth and Arlington. The project's viability is genuinely uncertain. Shift to Japan, where the relationship between a nation and its trains borders on the spiritual. In 60 years of operation, Japan's Shinkansen bullet trains have recorded 0 fatal accidents. 0. That makes them one of the safest forms of transportation in human history. And now, Japan is pushing forward with perhaps the most ambitious transport infrastructure project in the world, the Chuo Shinkansen Maglev line. This isn't just fast rail. Magnetic levitation means trains that literally float above the track on a cushion of electromagnetic force. On April 21, 2015, the L0 series test vehicle set a world record of 603 kilometers per hour, 375 miles per hour, faster than many commercial aircraft at cruising altitude. The concept itself stretches back more than a century. In 1905, German inventor Alfred Zeden developed the basic concept for the type of motor used in maglev systems. By 1941, several patents had been lodged in Germany. The first commercial maglev system launched in 1984, a modest 600-meter shuttle connecting Birmingham International Airport with its nearby railway station in the UK. But Japan's Chuo Shinkansen operates on an entirely different scale. 286 kilometers of maglev track, the largest such project ever built, at an estimated cost of $67 billion. It was supposed to open in 2027. In 2024, JR Central announced it would not meet that target, and the reason is surprisingly human scale, a tunnel in Shizuoka Prefecture. The local government has opposed construction for 6 years over concerns that excavation would impact river water levels. It is a reminder that even the most advanced engineering in the world can be stopped by environmental concerns and local politics. The opening is now expected sometime after 2037. Across the Indian Ocean, another mega project is taking shape. India's Mumbai-Ahmedabad high-speed rail corridor stretches 508 kilometers and will feature 12 stations. When complete, it will slash travel time from roughly 6 hours to under 2 hours with a design speed of 320 kilometers per hour. As of 2026, 357 kilometers of viaduct have been completed, and all 1,389.5 hectares of land have been acquired. In January 2026, workers achieved a breakthrough on a 1.5-kilometer tunnel connecting Virar and Boisar. A second mountain tunnel breakthrough followed in February. Railways Minister Ashwini Vaishnaw has announced that the first bullet train will run between Surat and Bilamora on August 15, 2027, India's Independence Day. In a fascinating development, India and Japan have agreed to fast-track the project by beginning operations with an Indian-made high-speed train before Japan's next-generation E10 series, Shinkansen, is ready in the early 2030s. Back in Europe, the UK's HS2 project has become a cautionary tale. Originally planned as a Y-shaped network connecting London, Birmingham, Manchester, and Leeds, it has been systematically stripped down. The eastern leg to Leeds was cancelled in 2021. The Phase 2 leg to Manchester was cancelled by the previous government and has not been reversed. Land on the former routes is being sold off. What remains is the London to Birmingham line, and even that has been scaled back. In May 2026, the government confirmed a lower maximum speed of 320 kilometers per hour and abandoned plans for automation. First services between Old Oak Common and Birmingham are expected between May 2036 and October 2039, with the full route potentially not complete until December 2043. The journey time, about 45 minutes compared to the current 1 hour and 21 minutes, is impressive, but the question lingers. Was it worth the cost and controversy for a single line that keeps shrinking? And then there's the technology that was supposed to make all of this obsolete, Hyperloop. When the concept first gained mainstream attention, it felt like science fiction made real, pods traveling through low-pressure tubes at speeds exceeding 700 miles per hour. Virgin Hyperloop received a massive boost in 2017 when Richard Branson's Virgin Group joined as an investment partner, helping secure more than $400 million in funding. In November 2020, executives Josh Giegel and Sarah Luchin became the first human passengers, reaching speeds of 107 miles per hour at the DevLoop test site in Las Vegas. But 107 miles per hour in a test tube is a long way from a commercial system carrying thousands of passengers. Virgin pulled out in 2022. The company reverted to its original name, Hyperloop One, and pivoted to carrying cargo in unmanned pods. Then, on December 31, 2023, it ceased operations entirely. The dream of Hyperloop, at least in its original form, is dead. Which brings us to the bigger picture. The International Energy Agency says a new high-speed rail line can produce almost immediate net carbon dioxide benefits by reducing air and car journeys. High-speed rail has been shown to reduce aviation on the same routes by as much as 80%. A study on Midwest high-speed rail projects says it could cut carbon emissions by 3.3 million metric tons annually. California's system alone could save 2 million metric tons of carbon dioxide equivalent per year, the equivalent of removing 400,000 cars from the road. Environmental advocates also point to real trade-offs: habitat destruction during construction, noise pollution affecting communities near the tracks, and the significant carbon footprint of building the infrastructure itself. These are not reasons to abandon high-speed rail. They are reasons to build it thoughtfully. The completion of Europe's 10T high-speed network by 2040 carries an estimated price tag of 345 billion euros, with expected net benefits to society estimated at around 750 billion euros. High-speed rail projects will be prioritized in the 2026 Connecting Europe Facility call, paving the way for further investment through the 2034 EU budget. So where does all of this leave us? The future of high-speed rail is not one story. It's dozens of stories unfolding simultaneously across the globe, each shaped by different politics, different geographies, different ambitions, and different obstacles. China is building its second generation of high-speed rail, smarter, faster, more automated. Japan is trying to make trains fly. India is tunneling through mountains. The United States is struggling to build what much of the world already has. What's clear is that the age of megatrains is not some distant fantasy. It's happening now, unevenly, chaotically, and expensively, but it's happening. The question is not whether high-speed rail will transform global transportation. It already has, for the billions of passengers who ride these systems every year. The real question is, which countries will be part of that transformation, and which will spend decades debating it while the rest of the world speeds past?